we're finishing up our network scanner. However, I'm going to give you a preview of how far you can go with it. There's I think that's my last version that I was working on this. I made it object oriented. I added in rich. I added in Mac vendor lookup, which was kind of fun. Let me pause because obviously I don't have Mac. All right. So Mac vendor lookup is yet another Python library. And what do you suppose that library does?
What's a Mac vendor?
Yeah. And you can integrate in your program. You notice that in the Nmap and other things we've used to scan, it gives you the Mac vendor, the Mac vendor like Dell or whatever the weird thing is for GMGH for VirtualBox. It gives you all that. Well, it's a pretty complicated library, which is fine. We don't have to know how the library is programmed. We just have to know how to use it. And it took me some research to figure this out. And one of the places I went was pypy.org, and that helped me get started. So I used this documentation to figure it out. So this is a little more complicated. I'm just going to run it, and then we'll go back to the other one just to show how cool it looks. Oh, I don't have rich installed. Oh, I do have rich installed. Okay. So we put in our network address. Oh, I'm at home. At 0.1.0 in a 24-bit network or a 255.255.255.0 network. The first three define the network. The last one defines the host. Well, 0 can't be a host in this type of network. So 0 is the network address. And 255 is the broadcast address, which you also can't use for a host. You can use 1 through 254 as a host address. When you want to designate a network using the shortcut method, you do /24, which is the same as 255.255.255.0. Now you can see why they invented /24, right? Cut down on the typing. Lots of programming things were invented to stop, to make things, not only programming, but networks. Everything was designed to make things go faster. So there's more than one way to do something. This is like the way that's very short. Some firewalls will use this. Some firewalls will use both. Some firewalls only do 255.255.255.0. Depends on the firewall. Commercial firewalls typically will use this or the other one. Home firewalls typically use 255.255.255.0. Just because that's the easy. Oh, look at there. I'm scanning my network. This is not threaded either. Uh-oh. Oh, I don't think I updated my database yet. Yeah. The first time you run this, you have to update the database that loads on your computer. So that's what that does. Update vendors, and I forgot to do that. Now it'll work. It was giving an error because there was no database. If the MAC address is not in the database, I have it set to print out none. So it doesn't give an exception. That exception is because I didn't have a database to begin with, which I should have caught that exception and said, hey, update your database, buddy. There we go. We are scanning. It took that little pause in there. It was downloading the MAC address database. And look at there. How about that? Pretty fancy, huh? Yeah, I developed this before AI. Now, just to save time, oh, look at that. I don't know why that's in there. It's in there instead of a colon. Isn't that interesting?
It's CD is because this console terminal automatically converts some sequences of symbols to emojis.
I didn't notice this last night because I don't have a Netgear in my network. But for some reason, this company range eats up this middle part and it thinks it's a CD symbol. Huh, interesting. Well, this gives you an appreciation of how complicated Nmap is. It gave me an appreciation of it. Found 34 hosts because I turned on all the computers this morning. Anyway, we're not going to go that far, but it is possible. That's at that point, then I had to move on to other projects because I did all kinds of other things. All right, so let's look at the stage we're at, and this is the final one. We need the Scapy module. And this looks very much the same as the first one that we did. We have our main function. We have this in here so that if we decide to use this as a module, we can use it as a module. If we run it directly, we can run it directly from main. So it's when you break something up into functions, notice there's no self here, a function, because this is a simple program, it really doesn't need to be object oriented. It's not passing anything around. It's printing things right in here. You know, so it's just one function that does everything I want. Should I have divided this up into separate functions? Probably, but for this example, I didn't. So we're printing out a nice heading. Where am I at here? Oh, I set my default network, which this is a good find. When I found that, I thought, well, that makes it a lot easier when you're testing. I'm setting my IP address range, which is a text. It's a string that's being put into my scan function. And I probably should have put that in here. This is called typing, meaning I'm putting in a data type here. So if I go down here and I point at this guy, it says string. I can also add other things in it. Oh, this should be showing up as a, if I point at scan, this brings up the doc string. Which those are two good ways to document your code, because you don't have to know even what the address, what the function does, but you do need to know how to use it. And that's what this gives you. It says, this is the type of input I want. I'm not returning anything. And here's some examples of how to run this thing. So regular libraries do the same thing. Okay, moving on. So I'm just saying scanning IP address range. All right, scapy.arp. We've done this before. Our destination, right, is our IP address range. And I put that into here because that turns this into an ARP request, meaning I'm saying, who the heck is everybody on this network in that range, 1 through 254? And then I'm putting a broadcast address together with it. FFFFFF is the last number in a hexadecimal digit. We don't type in, if we had to type in, here's another example of why people do things. If I had to type this in with binary, it'd be like, I'd have to keep going clear off the edge of the page and then into, you know, the next century. So they developed or started using hexadecimal, which is base 16. Yeah, base 16. And so you can store a lot more numbers, 16 numbers inside of each one of these characters. But it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, A, B, C, D, E, F. So that represents the binary. So we are, actually, this doesn't represent binary. It represents the binary address. It's a string. When the ether looks at that, it says, oh, you want this in binary, and this is the broadcast address, because everything here is now binary, because we can't just, well, we're telling the operating system to send it out in binary. How about that? That's what we're doing with this, because this interacts with the operating system. And it tells the Ethernet card, send out a broadcast asking for everybody's IP to a MAC address resolution. That's what it's saying. Well, we're going to send out this. This actually sends the request. We're only going to wait 2 seconds. I think 4 is the default. I'm tired of seeing the feedback. I just want the answers. So how did I figure these out? Well, I went to the Scapy. Oh, I didn't put that in here. Scapy has a PyPy place too. I need to put those in there. Now this is a method returning a list. I don't want to have 2 lists because this method returns actually 2 lists. It returns answered and unanswered. All I want is the answered packet. So I say 0 because lists start at 0. So I'm only getting the answered list. And that's why we had 2 of them before. I wasn't adding this little guy on. I could also, oh, maybe I should have done it that way, split it up into two things. I might do that later. So how I could have done this in two steps, which might have made more sense, is there's really not a good way to do it other than this. This shortcuts the whole having two lists thing. I'll have to think about it. So for every element, this is a for next loop. For every element in the list, we're getting the first element. Then we get the second element. Then we get the third. So it starts at 0, 1, 2, 3, 4, 5. For next list, a list has what's called an iterable in it. Iterable means it goes from 0, it goes through every one until we're finished. That's what iterating means. It's like a loop, except the loop automatically quits at the end. It's not really a loop, but it's like a loop. So this gets all the elements that are on the list, which are only the answers. Then we print them out. Now look at there. How do I know which things to pick out? Well, you remember we were printing out things that had all that information in it. I went through that and figured out which element of the list the IP source was, which is the source of the response. So if I send out this broadcast, Sean's going to say, my IP address is such and such. So he's the sender, the source, and he's going to say, this is my MAC address, which is the sender, because you're sending a response to my broadcast. And then we print the answered list. Okay, I did a bunch of typing. Hopefully I didn't wreck it. Sometimes I do, and then I come back later on another class and I'm like, oh, what did I do here? So I put in the same thing, and 24, and it scans for about 5 seconds. And there we have it. All we have is all the MAC addresses and the IP addresses. So this exactly looks like the ARP cache. That's what this is. It looks like an ARP cache. Got 34 hosts running, which includes firewall, wireless access points. Host is anything connected to the IP network. And there we go.
Your other one was very more intuitive because it also listed the vendor, because then you could look up the vendor to see what kind of vulnerabilities they had on that particular item.
Yeah, it's not hard, and I've thought of adding that in there because I did a bunch of other things, but I could add this in. I don't have to update the vendor anymore because I already updated it once.
Or you just saves time, I guess, looking up, instead of looking up the MAC address to see what the vendor is.
But there's a purpose to
know
that.
what is there.
Well, there's a purpose to that also, is that you can look it up because you won't always have a piece of program like this.
Yeah.
Anyway, here it is. So we go through the element in each answered list. The MAC object that I created somewhere up here, I can't remember where I created it. Yeah, there it is. There's my MAC object. It wouldn't be hard to add that in. It has a lookup of the MAC address, returns the company. So we could add that in. It's not very hard. I mean, it's a pretty simple little library. It only does one thing. It looks up MAC addresses and returns the vendor, which is perfect. That's all I needed. And I don't have to add it to a dictionary. I just did just because it was easier to do. Because a list can contain dictionaries. But notice this is the same thing. This is the same thing, MAC and IP. The only thing I added was company. And I didn't have to do it like that. I just chose to do it at that point. I can make it simpler and add it into number 4 because it is kind of fun. And it's an example of a very simple library that does one thing, and that's all it does. And if you want to find out what it does and how it works, you go to the MAC, and there it is. It was released in 2022. It works. And I'm hoping they keep up the database of MAC vendors because most of the time it has the right stuff. But look at here. It kind of gives you exactly what to do, and that's all it does, which is fine. That's all I needed. Create the object, you update the vendors, and then you do mac.lookup. So that didn't take me long to figure out. But it requires more experience than just,